So, hello everyone, thank you for coming to this session. And what we are going to do is for the next 40 minutes or so, we are going to talk a little bit about CI/CD, about pipelines, about delivering code to production, and we are going to see which part we are missing. Whenever we do deploy something to production, whenever we do go through like regular CI/CD stuff, we have unit tests, we have code reviews, we have other stuff, but generally what we miss is we don't have any good reasoning whether the code we are going to deliver to prod is going to work well with the production database. Is this going to scale well? Is it going to fly well with the amount of load we have in production, potentially in different country, with different data distribution and completely different data load? So in this session, what we are going to see is how we should get these things sorted out and how we can improve the current state of the art, no matter whether we are a small company or big Fortune 500 stuff. So let's move on. A couple words about me before we begin. I'm a software engineer with nearly 15 years of experience now doing back and front and various stuff, and also very interested in all the internals of the processes, debugging stuff, etc., etc. And now what we would like to see is how we can dive deep into protecting our databases and making sure that we prevent the bad code from reaching production. Because in today's world, it's a must for us that whatever we do, we try and we need to capture all the issues, find all the issues before we actually go to production. It's a must for us. No matter whether we're a small company or a big one, we need to capture issues before we actually deliver to our customers, right? So what we want to do is we want to make sure that things don't break. We want to have checks in place, guardrails in place in various stages of our CI/CD pipelines. And most importantly, we would like these guardrails to act in as early as possible. The worst thing that may happen, apart from obviously finding issues in production, is learning about the bugs and that our approach is not going to work well at the end of the funnel, at the end of the CI/CD pipeline, right? What we need to do is we need to find those issues as early as possible. We need to push those checks to the left of the stages so that happen as early as possible, ideally when developers are just writing their code. And the second important part is, even if we deploy something to production and things work well today, they may break tomorrow. They may break because of different configuration, different data distribution, different like weekly patterns of the data coming to our service, right? If you're running a video streaming service, then probably if you deploy on Wednesday, that doesn't mean much because your customers will hit your service the hardest on Saturday evening, right? That's when they're watching their soap operas and whatnot, right? But if you're running e-commerce for logistics or ticketing stuff, then probably you have to peak hours twice a day, right? In the morning and in the afternoon. So if you do deploy on weekend, then you don't hit the peak hours that will actually take your application down. So what we need to do also is we need to monitor and get good observability of everything that we do. And if things go wrong, we need to automatically troubleshoot the stuff. We need to have this automated to connect all the dots together to see all the context of the stuff we are running in. So let's see actually how can we know whether our code that we deploy to production is going to work well over there? Well, obviously, the first question we need to answer is what could go wrong, right? And when we think about that for a little bit longer, we realize that, well, there are so many things that can break, right? Starting with deployment may go wrong, right? We know Linux, Windows, macOS, different line ending characters, different Docker parameters, --net equals host does not work on Mac. We all knew, we all been there, all done that, right? Those are the things that we can figure out or we can find them out to some extent with our unit test before going to production. But some things are also heavily depend on how we deploy the stuff, right? Connection strings, IAM roles, permissions to our client APIs, etc., etc. We do deploy, we test stuff locally, we deploy to non-production environment, we test stuff over there, it works, we deploy to production, bang, we forget to do some stuff, right? So how can we figure out that things are going, like how can we guarantee that the deployment to production will work well? Other stuff that may break obviously is our code may fail. Apart from some obvious bugs that hopefully we catch with unit tests, integration tests, etc., etc., we also face different data distribution when we go to production, right? We tested our application in the US, we deployed to some tiny country in Europe, and bang, we have completely different stock, completely different data in our data storage, and bang, our application just hits completely different edge cases, right? Other thing is we do deploy stuff that worked well on our machine, does not work well in production because of different locale, different format of dates, different strings, different character encoding, etc., etc. So those are the things. Some of them we can capture with CI/CD, with unit tests. Some of them, they are much harder for us to spot. And finally, the hardest part when it comes to databases is the load we get in production. Right? We do deploy to production and we get completely different traffic, different data distribution, different data access patterns, and finally completely different load, many more transactions, scalability, etc., etc. How do we figure out during our CI/CD pipelines that our application is going to work well? And obviously the answer they all give us is CI/CD. Yeah, so we know CI/CD, and CI/CD is going to solve all of these issues. Just to set things straight, I guess all of you know that, but just to make sure, CI, continuous integration, stands for merging changes to like one common branch, building a package, running unit tests, integration tests, end-to-end tests, whatever else to make sure it works. CD stands for both continuous delivery, which is deploying to non-production environments automatically. This could be some testing environment or some team environment that like other microservices use or whatever. And finally, CD also stands for continuous deployment so that we push to production automatically, and no matter what time of week it is, no matter whether we are in the office or not, no matter whether we have pager duty, etc., we just deploy to production, right? And they tell us, hey, you have CI/CD, you have tests in your pipeline, bang, you are good to go, right? And the reality is things may go wrong. So for some time now, we are going to see which things we miss in our CI/CD pipelines, which things we actually do not cover with our CI/CD as tests, stages of whatever, and what can go wrong actually around databases, ORMs, and finally the lack of observability. So let's begin. So problems with databases, we could group them actually in like 3 different areas. First area is obviously code changes. We did change our application, so now the application started sending completely different SQL queries to our database, right? Easy enough to test them with unit tests to see if we get like proper outputs, proper responses. However, still, this may break when we are talking about heterogeneous applications. We'll get to that a little bit later. The other thing that may break is schema changes, right? You do have schema changes in your applications. You add columns, you drop columns, you add tables, etc., etc. When you do these things locally, they always seem to work pretty well, right? But when you deploy things to production, then just adding simple column may actually take minutes, if not even hours, right? Because you need to rewrite the table. You need to copy the data from the table on the side, modify the table, copy the data back, right? And this is something that when run locally takes probably a second and we don't even notice that it's happening. But when we go to production, it may take hours and basically take our system down. But the other thing is query changes, meaning that nothing changed in the application code per se, but the database configuration changed for some reason. It has different indexes configured, different extensions installed, different running configuration when it comes to connection pooling, etc., etc. And bang, now it happens that your query executes differently, meaning it uses different join strategy, it uses different indexes, it extracts data in different order, which makes it like much slower and just can't keep up with the load. How is CI/CD going to protect you from that? How are you going to check all those things before going to production? And that's just the beginning. The other thing that we may hit and that are like very hard to spot with CI/CD is slow queries. Let's start with this straightforward example. Let's say that we have this application code. We want to get the aggregate user, which is called here, and user has some additional data connected with it, like details, text, reports, peers, whatnot, right? Okay, this is actual code from the production system I was debugging once. What happens if you run code like this in your production? Well, it generates a SQL statement like this one. So you can see that we do join multiple tables to get this one big aggregate root, right? If your database locally has something like circa 100 rows, this is going to finish in a split second. If your database is the production one, this reads around 300,000 rows, which are then delivered to your ORM, to your application, and then mangled together for 25 seconds just to build one JavaScript object. Okay, so this is something that your unit tests, are they going to spot that? Well, from the, let's say, correctness point of view, this thingy works well. It returned the user object, right? But from the performance point of view, this is something we probably won't catch easily. How can we fix that? Well, at least in that case, what I had to do is I just split that into multiple calls to the database. So instead of having like one big aggregate, I was basically querying the database multiple times. And then what I was doing is I was merging all of that stuff together in the application code. One might say, ooh, that's a big no-no, because hey, now you have 8 or so different like SQL queries going to the database. And well, they would be right. But the difference is this thingy finishes in like a millisecond. Just because it's not getting 300,000 rows out of the database, but it's just getting smaller chunks, smaller pieces of data, which is way faster thanks to indexes and whatnot. The problem with this is if we are running this like tests against this piece of code in our local environment, staging environment, pre-production, where we have like 100 rows in the table, then we won't capture that there is an issue. Not at all, right? The problem will manifest itself only when we deploy to production, and our CI/CD will not protect us from that. Moving forward, what else can go wrong? Have you ever used ORM libraries? Hands up if you have. There are some hands in the air, yes. Now, if you ever had an ORM creating a query for you, you may have learned that, hey, it may generate queries that are equivalent in terms of correctness or the output they produce, but completely different when it comes to performance. So let's take this example. We have a table which is called boarding passes, which has something like 8 million rows in total, and this is a handcrafted query just to show you the problem. Let's say that we take all the rows from boarding passes, we calculate the MD5 sum of the ticket number twice, and then we just filter the stuff based on some condition just to extract some particular rows, okay? And in this query, what we do is we use CTE, common table expression. This is kind of like temporary table named so that it makes the code a little bit easier to follow. And equivalently, what can happen is we have another query that does exactly the same, but it doesn't use CTE at all, but just calculates this hash twice in the where condition, as you can see here. If you were to guess which query would execute faster, I don't know what your pick would be, but mine was CTE is going to be better in this case. But then I learned that CTE is often super slow, and in this example it's 13 seconds for the top query with CTE versus 8 seconds for the bottom query without the CTE. CTE increases the code readability at all, decreases performance at the same time. Is your CI/CD pipeline going to catch that? I guess it's not. So this is yet another thingy that may break when we are dealing even with like refactoring, let's say. I wanted to refactor the bottom query to the top one to make it a little bit more readable. All the unit tests are green, everything works great. I deploy the prod, bang, it's dead. That's something we would like to avoid, but our current CI/CD pipelines cannot capture that. Moving on, changes in schema, incompatible changes mostly. So adding a column seems something like we should always be able to do. And apart from like correctness, we'll get to that in a sec, this may actually take minutes or even hours. If you add a column somewhere in the middle of your table, then you may need to rewrite the whole table. Copy data on the side, recreate the table, copy data back. This is basically taking your table down for some prolonged time. Your application cannot work during that time, right? No matter how scaled out it is. It just can't work because the migration is flowing in. Another thing that may happen is if you add new column, you may break other applications if you have heterogeneous context. Imagine that you have one database that is accessed by multiple applications written in different technologies, different languages, yada yada. So what can happen if you introduce new column? Your ORM or ORM of any other application may just simply reject the query, and because there is a new column that it cannot recognize, it doesn't like the schema, etc., etc. So ORMs even will step in and remove this column just because the schema drifted apart. Another thing is dropping a column. Again, if you run in a heterogeneous scenario, then obviously there is a big risk that some other application still relies on this column. But even if you don't run in heterogeneous context, but you just do the rolling deployment. Then what you have during the deployment is you have 100 nodes running your application. Half of the nodes are already deployed and running the latest version, and they expect that the column is not there, which is cool because it was dropped, right? But the other half is still being deployed, and they still would like to use this column, right? So now what happens is you need to have much better deployment process and much higher like compatibility maintained. You need to maintain this compatibility to make sure that nothing deletes this column until you actually deploy all the nodes. Is your CI/CD going to check for that? Probably not, because you will be just running against the new database schema with new database code, and all unit tests are green. Even changing the column type may be very tricky. That's because first, you may need to rewrite the table, and second, just because you change the representation of your type, some languages, some ORMs, some libraries may actually go crazy and not recognize the data anymore, especially when we are talking about like spatial data. How do we keep coordinates in our database, and how is ORM holding that in memory, right? So generally those things we need to make sure they work well, but if we just run them in isolation with our CI/CD tests, then we won't see that, hey, there was some other application that was actually like, I'm not expecting the issues that happened. Moving forward, missing indexes. Obviously when we run queries, they run fast because we have 100 rows in our local database, but when we realize in production things do not work well, what do? We need to add indexes. And now comes the question, what kind of index? How long does it take to build an index? Building an index may not be like a second or 2 seconds. It may be actually even like long minutes or even hours, especially when we are talking about like full text search indexes or gist indexes for trigrams, etc., etc. But the worst part is, if we tell junior developer, your query is slow, you should add an index. What do we end up with? Exactly right. Index on every single column. And what is the problem with indexes on all the columns, right? Indexes, they do improve the performance of querying the data, but they slow down things when it comes to modifying the data, right? Adding entities, removing entities, changing entities. We now need to update like tons of indexes just because we have index on every single column. Not to mention that those indexes kind of drift apart, meaning that, hey, there was an index that was very useful like 6 months back, but isn't used anymore just because we changed the application code. But the index is still there, needs to be maintained, needs to be kept up to date just because it is configured in the database. But our unit tests, our CI/CD pipeline have no idea that there is such a problem, right? How can we figure out we should remove such an index to improve the performance, right? Moving on. When it comes to bugs, obviously apart from bugs that we all done some point in our career, like running delete without where, and other bugs that we hopefully capture with unit tests, there are also bugs in the SQL engine or any database engine. Have you ever heard about the Halloween problem? Hands up. I don't see hands. Okay, cool. So this is actually a funny story that we all are now protected from. So back then, 40 years ago, there was a company. They wanted to give some salary raise. So they wanted to run a very innocent query that you can see here on the screen, which was, hey, update the employees, increase salary by 10% for all the employees that earn less than 10,000. Obviously that, oops, sorry for that. That was not necessarily the query, but you get the concept how it's being done. And now the problem was the database they were using wasn't protecting itself from the Halloween problem because, well, no one ever figured out there is such a problem. So the database worked in this way. Let's take an entity. Let's see if the salary is below 10,000. It is. I increase it by 10%, and then I move on. And at some point later on, I spot exactly the same entity. Is it below 10,000? Still is. I increase it by 10%. And bang, this way, everyone in the company was earning at least 10,000. Because this happened on the last day of October, that's where the name comes from. So this is Halloween problem. Or your databases are now protected from the Halloween problem, hopefully, right? But we all been told exactly the same. Mongo is like bulletproof and doesn't lose data, right? We've all been there, done that, right? So our databases also have bugs. And we also may hit some weird database edge cases that will cause problems, issues, etc., etc. How do we figure that out with our CI/CD pipeline? That's another problem. Moving on. That was for the databases, but ORMs, and this is how developers typically use their databases, ORMs introduce another like group of issues that we may face. One of them is well-known n+1 selects problem. So imagine that we have like a table that we call aircraft that is in relationship one-to-many with the table called seats. So if you would like to get all the aircrafts, and then for every single aircraft we would like to get the, I don't know, number of seats that a given aircraft has, what may happen is we write the code, application code like this one on the left, and this may in turn generate n+1 queries. Why? Because in the first query we go and extract all the aircrafts from the database, and then for every single aircraft we get additional query to get the seats for that aircraft, right? So this results in n+1 queries in total. One query for the aircraft and additional n queries for every single aircraft we extracted. What can we do about that? Well, we can reconfigure our ORM so it is not lazy, but it is eager instead. Eager meaning that it will extract all the data from the database to create a full aggregate route to build the object so we can iterate over that easily. When it comes to technicalities behind the scenes, this would mean that instead of sending like this many queries, we would just send one query with left join, okay? But the problem with this is you don't know based on the application code whether this is going to run eagerly or in a lazy mode, right? You don't see that from the application code because your configuration of ORM is stored somewhere else. Not to mention that your unit tests are not going to check for the configuration, they will just check whether you have proper results, and results are equivalent in both of these sets. But it gets even worse. I just told you, hey, you go and reconfigure your ORM so it loads the data in an eager fashion. And then we get exactly the same issue we've seen a couple slides back, right? Because now we get 300,000 rows and process them in for like 25 seconds, right? What should we do in this case? We just need to change the queries that we send. It's not that there is no silver bullet in our case how we can configure the ORM to see how things work or to get them working right. It just doesn't work like this. We need to be really aware of what's going on behind the scenes so we don't fall into like stupid mistakes just like here. But things get even worse with ORMs. One thing is called impedance mismatch, because we have now two completely incompatible worlds, one of them being like SQL databases and relational model, and the other world is object-oriented programming. We have like troubles with representing one with another. How do we represent inheritance hierarchy in our database? Does our ORM support that? There are obviously patterns just like listed on the screen, for instance, table per hierarchy or per type, but generally representing inheritance hierarchy is not straightforward with SQL databases. Why? Because this is completely incompatible model. That's the thing. But this can get bad even with very simple things. For instance, data types. I briefly mentioned spatial data. How do we keep spatial data, so basically coordinates on the planet, in our database, and how do we extract them to our ORM and to our application code? Should those be like pair of numbers? Should it be stringly encoded type? Does our ORM support even the spatial data? Tons of ORMs have no idea how to do that, right? So you need to serialize that, you lose performance, you lose the precision and whatnot. But we don't need to use spatial data to get things like this one. How do we go even with strings? With text, like our applications, JavaScript, .NET, Java, yada yada, they have just one type which is called string to represent like the text literals, right? But SQL databases, they let us configure a thing that is called collation. So we can configure the order of characters, whether lower characters should be like lowercase characters should be less than uppercase characters, or maybe that should be equal, and whatnot. So generally this is something we can configure with our SQL database, but we have no way of configuring that in our application code. Similarly with like decimals or numeric type, okay? In our applications we have float and double, and that's basically it. In databases we can even specify the precision, right? How do we do that? How do we capture those issues that, hey, there may be some impedance mismatch in between? ORMs, they generally hide all the configuration from us. Hands up if you do know what's your database isolation level. Okay, I can see a couple of hands in the air. And if you do not know what your default isolation level is, then most likely it is read committed. And read committed allows, according to the standard SQL 92 or 93, don't recall the year exactly, it allows to either skip the rows from the table when doing select star or get the same row twice. This is perfectly allowed according to SQL standard. Ever laughed about Mongo losing data? Your SQL database can do exactly the same, right? And if you don't know what your default isolation level is, then how are you going to figure out there might be an issue? And ORMs, they hide that. Another thing is who begins the transaction, who commits it, who rolls it back when something goes wrong. And you have nested transactions. Do you cache data between transactions? What happens if you have 100 nodes in your application cluster and you have cache? Is this cache synchronized? Is it not? How do you figure that out? ORMs, they hide tons of these configuration keys somewhere around the application. They scatter that, like some is in like annotations, some of that is in some global default ORM configuration, some of that is somewhere else with like query hints and whatnot. Generally, this just increases the mess. Another thing is migrations. Who handles the migrations in your database? Is it like your ORM? Is it some external application? What happens if you use ORM that really doesn't like when your schema drifts apart and it wants to recreate the schema properly? So basically you add a column, it will just drop it, or the other end, right? How can you figure out those things are going to happen? Just with your regular CI/CD pipeline you have today. So just to sum up this area, like ORMs, they hide tons of complexity that we have by scattering in various places, by hiding the details of stored procedures, tables, triggers, functions, transactions, isolation level, whatnot. And generally when we are like using ORMs, it seems to be super straightforward. ORMs were supposed to make our lives easier, and how many times they actually made it much worse, right? So how can we fix that? Because this presentation is just not about ranting on the solutions, but about giving you some answer, right? In order to fix all of that, we need to have the root cause. We need to see what's going on. We need to have the context, and we need to have this context as early as possible to build proper database guardrails in our CI/CD pipelines. How can we get that context? Well, in order to understand what's going on in the databases, we should ask the database itself. So let's see what can the database tell us about the queries that we run against that. So whenever we send a SQL query to the database, or whatever query to whatever database, it's very similar in other solutions as well, the query goes through various stages. One stage is parsing the query into some well-known form and then rewriting it to some standardized form. For instance, you know that in queries you can use aliases, you can rename columns, etc. etc. All those queries are doing exactly the same, they just differ in like details of the naming, right? So we want to get rid of those details and build a proper standardized abstract syntax tree, and this abstract syntax tree depicts or represents the operation that we are executing. Then what happens is the database plans how we are going to execute the query, and this planning is actually showing what operators we are going to use, how we join the tables and whatnot, how we basically run the operation physically, and finally we execute that. So let's see what does it mean to plan the query. So if we take a query just like this on the left, we can always, in almost all the databases we have, we can always ask the SQL engine, hey, explain this query to me. How are we going to execute this query? How is it going to be physically executed? And what we get in response is this big thingy, typically is a JSON or XML, that represents the operation. And when we dive deep into what's that, we see that this execution plan consists of various nodes. Basically, every like row in this plan is a node representing some particular operation that our database is going to perform. And every node has like different type. For instance, it could be like bitmap, heap scan, index scan, sequential scan, or whatnot. Could be join of different type, could be nested loop join, hash join, etc., etc. But most importantly for us, every node has a cost associated with it. The cost is basically an arbitrary number indicating how hard it is to execute a given operation. How hard? Mostly in terms of like IO operations or operations that are slow and heavy for the SQL engine, but generally this is a number that we just can compare. Our SQL engine is now going to create multiple plans and then choose the cheapest one to execute the query in the fastest possible way. This is something that we can ask our database any single time. This is like for SQL databases, NoSQL databases, and based on that we can actually reason what the engine is doing and why, for instance, it's not using our indexes, yes? Once we have that, the question is, how do we get execution plans like this one? And what we can do is we can use OpenTelemetry. Hands up if you know OpenTelemetry. Yeah, there are some hands in the air. So OpenTelemetry is basically a modern standard for capturing logs, traces, metrics, providing and building proper observability into our applications. The idea of OpenTelemetry is it's like an open standard for building SDKs for various languages, no matter whether it's JavaScript, C#, Java, whatever. So those SDKs can instrument your application and extract signals, traces, metrics, logs, like human-friendly information about what's going on. And then what we can do, we can build the so-called spans and traces. Imagine that we have a workflow, for instance, I don't know, buying a ticket that uses multiple microservices behind the scene. So when the user clicks a button, it goes to our web load balancer. This load balancer then calls the database, some queuing, etc., etc. So we have those microservices talking to each other, right? What we can build is we can build a trace of this whole operation where each node is represented as a particular span. Span representing a single microservice doing some particular work that is like human-friendly, explained with name, timestamps, attributes, etc., etc. So this is what we can do. We can get this, and this is open source, this is freely available for you. Just click one button, npm install or whatever, and you have that in your application, and your frameworks already integrate with that. Now, what can we do? We know we have execution plans, we know there is OpenTelemetry, so we can get all of that. But when? The regular answer our CI/CD pipelines would give us is during load testing. So we load test our application at the very end. We get all the queries sent to the database. We analyze their execution plans. We see the timings. We know whether it's going to scale well or not. But there are problems with this approach. First, this is super expensive because load tests are expensive and take time. Not to mention that sometimes we need to pay for very expensive hardware. And second, those load tests happen at the very end of our pipeline. So when we as developers implement some code, we get the feedback after running things through the pipeline. After merging, code reviewing, deploying, it's only then when we run the load tests. It's way too late. So what can we do? We need to be proactive, and we need to push all of that to the left. We need to build completely novel approach, which is database guardrails. We need to use OpenTelemetry and extract all those things as early as possible to analyze that stuff and to tell our developers as early as possible that things are not going to scale well in production. And how can we do that? Metis can do that for you. So Metis is basically a nice product that you just drop to your application and you get all I told you about. So let's start with when you register in Metis. This is based on open source, telemetry, etc., etc. You install one dependency into your application, and what happens is you get immediate feedback that, hey, your application is, for instance, exposing those REST endpoints, and when you hit this REST endpoint, you get, for instance, HTTP 200 as a response. But more importantly, those are the SQL queries that have been executed behind the scenes. And this is something you can get locally. You don't need to wait for load tests to happen. You get those things locally, and because this is developer-centric, it immediately tells our developers, this is not going to work well in production. Critical. Think about fixing that, right? You have like the impact, you have the remediation plan, you have all the details how to fix that thing, right? If you want to learn more what happened exactly and why this is critical, sure, You can get the SQL statement. You can, for instance, get the metrics about this query execution. You can get the nice visualization, like the query tell of all the operations that happen in the database, right? You can get the execution plan if you want, whatever. But most importantly, you get those insights telling you whether this is going to work well or not. And you can integrate that with your CI/CD pipeline. So for instance, you drop one YAML line of code, and bang, whenever you run pull request in your GitHub Actions, Metis is going to analyze things for you. It's going to analyze the performance. It's going to analyze, for instance, the schema migration, so it can tell you that, hey, you are dropping this index that might not necessarily be the best query to execute, and whatnot. So you integrate that into your application, you integrate that into your CI/CD pipeline, and now you get the immediate feedback right at the moment when you're typing the code. You don't need to wait for this feedback to happen when you run load tests or whatever, or even worse, when you deploy to production, right? What happens is you get that just at the moment when you're implementing the application. And apart from that, the other thing you can get is schema analysis for all your tables. For instance, like recommendations, there are no indexes, maybe you should add some. And obviously another thing, which is observability dashboard. Because, as we mentioned, pushing checks to the left is not the end of the story. The other part is when you deploy to production, things may break just because you have different data patterns, different data load, because it's different day of the week, right? And things change over time. Indexes you configured last week or last month may not be used anymore. So maybe, hey, find about those indexes, and Metis gives you this observability dashboard and can tell you, hey, this index hasn't been used for the last 2 weeks, okay? It can find the query statistics, analyze like anomaly detection on top of that, extensions, database configuration, and whatnot. So generally, you just drop one of that, one dependency, and bang, you have all of that. And this is what we should have. Because all our applications, no matter whether we are small company or big Fortune 500 corporate, we need to have those database guardrails as early in our pipeline as possible. We need to prevent the bad code from reaching production, and we need to have proper observability to automatically root cause when something breaks. So Metis gives you that, integrates with your source code, integrates with your CI/CD actions, and provides the observability for you in whatever case you need it. So just to sum up, databases may break. Anything that is storage related may break today, may break over time, just because we change the configuration and whatnot. This may be because we have changed our application code, changed the ORMs, or whatever else. And we need to be proactive, right? Waiting for load tests is just inefficient. If we wait for load tests to happen, then our developers are in completely different place now, and when load tests show there is a problem, we just wasted some time and need to start from scratch. We should get this feedback as early as possible, right when we are implementing our application. And for that, we can use modern observability tools, open telemetry, execution plans, and all the stuff around. And being all of that said, it's a great time to ask questions. So if you do have any, feel free to ask them now.